What's up, 7th grade? This is Mr. Pastel. Today we're going to continue with fossils and talk about how can you tell how old a fossil is once you dig it up. And there are two methods for this. The one we're going to go over today is called the relative age of rock, and it has to do with rock layers. So I'm going to start off with this analogy. Let's say that back when we were in school, you piled your worksheets on top of other worksheets in your homeroom box or whatever you had. So when you stacked the papers, one on top of the other, were the new ones on top or were the old ones on top? That's right, the new ones were on top, and rock is the same way. So, this is what we call the law of superposition. Newer rock layers are on top, older rock layers are deeper. How did they get there? Well, they are deposited through sediment. And we learned about sediment last unit. So we know sediment is caused by weathering, which is the breakdown of rock, and erosion, which is the movement of rock, and finally, the little pebbles and pieces of sand are deposited on top. So this is the relative age of rock. If Earth is like a layer cake, the youngest rock is on top, the oldest rock is on the bottom. So what does it mean if two fossils are in the same layer? Here we see the layers are not always flat sheets. Sometimes they bend a little bit. Sometimes the same layer can kind of be split up. Sometimes they can even invert or something like that. But if they're in the same layer, that means they were in the same era, ERA, or time period. So here are the main eras of Earth. Sorry about that car alarm. We recognize some of the eras from the dinosaurs, but even before the dinosaurs, there were some famous ones, like the Cambrian era had an explosion of new life. The Devonian was kind of like the era of fishes. These are the more modern eras. So this is kind of like the Ice Age and stuff like that. And today they're proposing that we're in a new era because humans are changing the world so much. And the Precambrian era was very simple life. So, just to show your understanding, let's say that there's a T-Rex fossil, but it's above a Stegosaurus fossil. What does this say about the T-Rex and the Stegosaurus? Were they together in the same era? Did they fight, like in the Disney movies or other movies? The answer is no, not even close. Actually, kind of a mind-blowing fact here. T-Rex lived 65 million years ago. Stegosaurus lived 150 million years ago. So if you think about it, we are closer in time to T-Rex than T-Rex is to the Stegosaurus. Again, we are closer to T-Rex than T-Rex is to Stegosaurus. So the dinosaurs dominated for quite a long time. Now, rock layers aren't always in clean, flat sheets. Sometimes they crack, sometimes they twist, sometimes they actually flip upside down. Sometimes magma goes through the rock layers, and this is because of plate tectonics, which we're about to learn about. Basically, tectonic plates colliding, tectonic plates moving apart, tectonic plates going under or over each other. So I'm going to give you a little puzzle here, which is not easy. Every color and pattern you see here is a different rock layer. And as you can see, they're no longer clean sheets. So this is not easy, but I'm going to ask you, how would you put them in order? How would you put them in order of youngest to oldest? Well, obviously, layer F is the newest or youngest rock layer because it's on top. It was just freshly deposited sediment, basically, soil. After that, if we keep going down, even though they're slanted, we can still go down. So after that, next youngest is B, the next youngest is K, the next youngest is N. Here's where it gets tricky. J is this layer that kind of looks like bricks, but we also have A, which is a layer of magma. So, sorry about my cat again. Which one is younger and which one was older? If you think about it, J formed first, and then A is magma that came up and then cooled into igneous rock. So actually, A is more recent than J. So after N would be A, then J, then D, then M. Then it gets tricky again. We know that C, L, G, and E go in that order, but we also have to think of H, which is a fault or crack in the rock. And if you think about it, H cracked after all four of these formed. So H would come after M. Or H would happen, yeah. H happens, then M happens, basically. So I shouldn't say H after M. But H happened after C, L, G, and E. So E is actually the oldest rock layer here. And this is what we call a rock layer puzzle. So I'm going to give you guys some rock layer puzzles, and your job is to put them in order, either from oldest to youngest or youngest to oldest. This one's easy. We'll do this one together. So for these four rock layers, which ones are youngest and which one? How would you put them in order? A is youngest, B is second youngest, C is third youngest, D is oldest. Or you can go in order from oldest to youngest. That would be D, C, B, A. This one's also pretty easy. It's just a flat. It's pretty clean layers there. Let's look at this one. The key to solving this one, after you go for the easy layers, layer F went through all the other layers. So that should tell you that F happened the most recently. For this one, A went through all the layers in a similar way, so A is the youngest. For this one, B is not the youngest, but B went through A, C, and D. So B happened more recently than A, C, and D, but not E. For this one's hard. We have two layers going through, so layer E goes through C and D, layer B goes through F and A, so see if you can figure that out. This puzzle has a fault line or crack D and a rock layer coming up through other rock layers E. You can tell that D happened more recently than E because D cracked E. I think D is the most recent event. And then you have some really hard. This has everything, and it's got a lot of layers, so that's hard. So your homework is to try to put those puzzles in order. Hope you learned something today about fossils and rock layers.